we learned that yes, you will bend away from the normal, but it'll be a slight bend to go along with the slight end difference. So this is a slight change. So this is a slight decrease. And there will be an ever so slight bend away from the normal. So it's a slight bend. In situations like this, you can probably imagine that the critical angle, which is the minimum bar to clear, is quite high. You have to go to a very, very large angle here before this will bend enough away from the normal to be recaptured. So for slight end value differences, the critical angle can be very large. The minimum bar for this phenomenon to start is a high bar. It can be hard to achieve. In contrast, if we have a huge end decrease, where the values are starkly different, you will have, accordingly, a very large degree of bending. So at this same exact incident angle I just drew for the other one, we're almost there now, right? I tried to draw the incident angle as being the same on the top there, but the degree of bending being much more extreme in the latter case means we're almost already there. So the critical angle here, where the party starts, is a lower value. It's a lower bar to clear. So that means that it's easier to achieve total internal reflection when the end values are starkly different. Now this is usually air, and usually that's fixed. So what we're really looking for is a large value for the material, and that will make total internal reflection easier to achieve. So total internal reflection is easier to achieve, which is to say the critical angle is lower. It's a lower bar to clear when delta n is larger, and since the n sub t, the air, is usually fixed, usually that means when the material that you're coming from and trying to stay in is larger. So total internal reflection is just easier to do. So that brings me back to a point that I made last time. I give you a kind of a little preliminary list of indices of refraction. I pointed out that diamond has an extremely high value. For the transparent, naturally occurring materials, diamond has a very high value. It's 2.42 compared to air for 1. So there's a more than double difference between them. Okay? Diamond is almost 2.5 times the index of refraction of air. That means that it's very easy to make total internal reflection happen in a diamond, and this is one of the properties of it that is desirable. It gives the diamond its twinkle. So the twinkle of a diamond